Okay, the first thing we need to do in this question is express this quadratic in that particular form. This is called completing the square. You can check up the method in your chapter 1 notes if you've forgotten how to do it. There'll be a mark for getting P and a mark for getting Q. Part 2 says write down the coordinates of the vertex of this point. Now it doesn't say hence, but you should always be looking for links between parts of questions. You need to remember that if you've got something, this is the same expression as we've got there, if you've got something in completed square form, then the vertex, the coordinates of that are directly related to the P and the Q values. They're not identical, little change needed, but write it down in the P and the Q values based on, the coordinates of the vertex based on the P and Q you found above. Then we've got to write down the equation of the line of symmetry of this curve. Now since this is a quadratic graph, its line of symmetry goes through the middle, it goes through this vertex. So all you need to know is what the equation of a vertical line looks like, and you need to use one of these two coordinates and complete that equation, and you have examples of this in your chapter 1 notes. And then we've got to describe geometrically the transformation. Now on core 1 there is only one transformation, and when you describe it you need a word and you need a column vector. Now the word you can look up in chapter 1 of your notes if you've forgotten. The column vector is very closely related to stuff you've already done. There's lots of repetition in this. If you're starting with a basic x squared graph that goes through the origin, where the vertex would be, if you know where the vertex is of your new graph, that gives you the column vector. So your answers to 3.2 and the column vector in part 4 are almost identical. Just this one's a column vector, not coordinates. And then in part B, this is a re-entry point. You don't have to have done any of that in order to get 4 marks on part B. We've got points of intersection. As soon as you pick that up, you're looking for simultaneous equations. And we've got the two equations of the two graphs. All we need to do is substitute, solve the quadratic equation, which will probably have x as the letter, so you'll have two values for x from solving your quadratic equation. Don't forget to get the corresponding values of y, and then put your answers as you're requested to in coordinate form. So you'll have two pairs of coordinates to finish off with for this 4 marks.